We want to prove by contraposition that 3n plus 2 is odd implies n is odd. So first of all, let's recall what a contraposition means. Well, we could have something like P implies Q, which would be directly proved by assuming that P is true and then reaching the conclusion that Q must also be true through axioms, theorems, etc. This would be a direct proof. But here what we want actually is to use the fact that P implies Q is logically equivalent to not Q implies not P. This essentially is what we call contraposition. Contraposition. And we can use this fact to reach the conclusion that not P must also be true, and then this will be logically equivalent to what we actually want to prove, which is P implies Q. So let me get these guys here, get rid of these guys here, and let's go to it. So what is P in our case? P is 3n plus 2 is odd. And what is Q? Q is n is odd. So what is not Q? Not Q is n is even. And what is not P is 3n plus 2 is even. So we will prove that if n is even, then 3n plus 2 is even. So we will start by assuming not Q, which means assuming that n is even. If n is even, then n can be written as 2k, k being an integer. Okay, every even integer can be written as 2 times any other integer. And if n equals 2k, then 3n plus 2 equals 3 times 2k plus 2, which is 6k plus 2, which can be written as 2 times 3k plus 1. And since k is an integer, then 3k plus 1 must also be an integer. And so here what we've got actually is another integer, because 2 times any integer, as we said before, is also an integer. So what have we proved here? We have proved that if n is even, then 3n plus 2 must also be even, which is precisely what we wanted. And that's it.